Welcome back everyone to this series of lectures on the Matplotlib figure object. And in part one, we're really just going to talk about understanding the figure object itself. So we just learned about the functional API calls we can do with Matplotlib for very simple plots using plt.plot. And then we could edit things like the Y label or X label, title, and then save that figure. However, the more comprehensive Matplotlib OOP API or object-oriented programming syntax makes use of what is known as a figure object. And so we have different layers here where we have a general figure object as a blank canvas, and then we add axes to this figure object, and then we plot on those set of axes. And this allows for very robust controls over the entire plot. So what we're going to do here in this particular lecture is quickly and visually build an understanding of the figure object itself before coding it out manually in Python. You should note that in these slides, I am going to be showing you a gray box for the figure object. However, technically speaking, it's not actually going to be visible when we code this out in Python in a Jupyter notebook. It's just this blank canvas. So let's go ahead and explore what this code actually looks like. The moment you call plt.figure, you're going to get a blank canvas created. Here, we're displaying this blank canvas as just this gray box with a empty white space. But keep in mind, like I mentioned, this is technically just completely white. You wouldn't actually be able to see anything. And so upon calling plt.figure, you create this figure object, and the default size is 432 pixels by 288 pixels, and then it'll also mention that it has 0 sets of axes. So right now you just have this blank canvas. And the reason for creating this figure object in general is now you can edit very high level attributes and properties that would affect your entire figure. For example, we could say, okay, inside of this figure, I want the entire figure to be 10 by 10 inches, in which case it would automatically size that up to be 720 by 720 pixels. But let's go back to just creating this PLT figure object. So essentially what we have here is a blank canvas, and the next step is to add a set of axes to actually plot on. To actually make this happen, what we have to do is say some variable call like fig is equal to the figure object. And then we're going to take that figure object and call the add axes method on it. And keep in mind, you can add as many axes as you want to a figure. Here we're just showing adding one set of axes. And so once you add that set of axes, you'll notice you suddenly get this axes showing up on top of your figure. And there's 4 key parameters here, which are the X and Y of the bottom left-hand corner in regards to the figure canvas. And then the second ones here shown 1, 1 are the width and height of the overall set of axes. So let's kind of play around with these numbers so you can get an understanding of the way they work in conjunction with the underlying figure canvas. So I keep mentioning that we have this underlying figure canvas. And so what we need to do is add a set of axes to it. And if we take a look at the first 2 parameters in this set of axes call, we have the lower left corner of the axes. And that is, again, all in relationship to the underlying figure, which means if you add a set of axes with 0, 0 as its lower left corner, that means 0, 0 in regards to the figure. So the lower left corner of the axes is the same as the lower left corner of the underlying figure canvas. Which means if you were to provide something like 0, 1, that means the lower left corner of your set of axes would then be at the top left corner of the figure. So for example, if you wanted for some reason your axes to start kind of right in the middle of the figure, you could say 0.5 by 0.5 as your XY. And again, this is all your lower left corner of axes in relation to the actual underlying figure canvas. So by default, most of your values will be between 0 and 1. However, they can go beyond 0 and 1 if you actually want to start drawing these set of axes outside of the figure canvas. Matplotlib is that flexible. So now let's talk about that second set of parameters, which is the width and height of the axes. So in this case, I'm saying that my bottom left corner should be at 0, 0, and then my width and my height will be 1, 1, which means take up 100% of both the width and height of the figure. So pretty much all these numbers are in ratios in regards to the underlying figure. So 1 means a 1-to-1 to the figure canvas underneath. So if I say add axes 0, 0, 1, 1, that would look something like this. The bottom left-hand corner of my new set of axes is at the same bottom left-hand corner of the figure canvas, and 1, 1 means I'm taking up 100% of both the width and the height of the figure canvas. So let's imagine I said 0, 0, but I set my width and height to be 0.5 and 0.5. That means that my bottom left-hand corner in regards to the figure is actually still starting at the bottom left-hand corner of the figure itself, so the axes matches up with the figure there. However, the width and height are only going to be half of the width and height in regards to the figure canvas. So we actually get a plot that would look something like this. So let's do another example. Let's say we said 0, 0 for our bottom left-hand corner, but I wanted 0.5 and 1 for my width and height. That means we start getting this narrower plot. So we get 0.5 for my set of axes on the width, which means we're actually only taking half of the figure, and then 1 means take the full height of the figure. So we get a plot that looks something like this. Okay, so then once you have that set of axes, you can start actually plotting on that set of axes. So here, I have my figure, have my axes, and then I plotted x and y on that. So the main steps here are just 3 steps. You create a figure, and then you can adjust high-level parameters on that figure, such as the figure size or dots per inch, etc. And we'll explore these later on. And then you add a set of axes to the figure. And keep in mind, we can add multiple sets of axes. Here we're just showing the simple example where you're adding one set of axes that matches up in size to the figure. And then once you've added that set of axes and assigned it to a variable, you can then plot on top of that set of axes. And a lot of these method calls, like plot on that axes, are actually going to match up quite closely to the method calls and function calls we just learned in the previous lecture. So what this allows us to do is to add in multiple axes as well as move and resize these set of axes objects, which means you could have a small figure right on top of a big figure. Now, this isn't actually a realistic example, but you could have something like an inset plot on top of a larger plot, or you can make 2 sets of axes be right next to each other. Now, as I just mentioned, in theory, we could set axes side by side using PLT figure calls to actually see multiple plots right next to each other. But typically, as we'll learn in later lectures, it's actually easier to use the PLT.subplots function calls for this. So we're going to be exploring multiple side-by-side plots later on, but for now, in this series of lectures, I really just want to explore and understand this figure object methodology for Matplotlib. So we'll see you in the next lecture where we actually begin coding this out and implementing it with Python.